Hello everyone, welcome back to Wetland Restoration, our 12th week. We're going to talk this week about restoring biotic communities. You'll watch a couple videos that show how to plant certain plants within restoration wetlands, and I think the how-to is pretty easy to get a grasp on, and simply going on YouTube and watching a couple videos provides a pretty good view of how to do it. Choosing the right plants is a different story, and understanding site trajectory and successional theory is kind of different than simply knowing how to plant a plant. First, I thought I'd give you a little background on plants and what the concept of a niche and some of the biology and physiological mechanisms are that plants use to respond to their environment, and how our understanding of plant biology and physiology can facilitate choosing plants that are correct for our wetland and planting those plants within specific locations of the wetland where they'll have success. So a niche, very broadly, if you haven't heard the word niche before, is a description of the ecological space occupied by a species. So what are the characteristics of that species environment, its habitat? This could include soil. What types of soils can that species survive and thrive in? And the hydrologic requirements of the species. Does it need flooding? Can it not withstand any flooding? A fundamental understanding of plant biology and physiology is necessary to really have success in a restored wetland, for those plants to have high survival and continue to propagate and put out new plants. So an example of this, understanding plant biology, a good example of this is willows. Understanding willow reproduction, both sexually from seeds and asexually from either underground shoots or simply breaking off limbs. Willows are adapted to life in adjacent to rivers. So a big flood comes through, it breaks off a branch. That branch then is deposited on moist soil, and that branch can grow new roots and send up new shoots and become a whole new willow plant. So understanding germination requirements and the water requirements of older willows is helpful because they're really quite different. Seeds require moist soil, which remains moist for a couple weeks for those roots to develop and grow. But if you go to an existing stand of willows, it might be very dry where those willows exist, because those roots can go down for many, many feet. Willows are what's called a phreatophyte. They access deep water tables. So the surface of the ground can actually be really, really dry, which makes you think that maybe willows can germinate on dry ground, but it's only because that ground surface has changed since the willow germinated originally. Switching over to some plant physiology, we all know plants harness some energy from the sun to make sugars, glucose. They then use that glucose for their own energy. They pull in carbon dioxide to use to create those sugars. But less people know that in order to do that, there are openings in the surface of the leaf called stomates. And those stomates have to be open for carbon dioxide to come in and for photosynthesis to occur. So plants take in water from their roots and carbon dioxide from these openings in the leaves. If you water your houseplants too much, or you put a plant in too deep of water, or you put a plant that needs deep water, you put it up on higher ground, the plant will close those stomates, take in no carbon dioxide, and essentially shut down that photosynthesis until adequate conditions are restored. If they stay closed for too long, the plant doesn't have enough energy to maintain its own metabolism and growth and repair, and that plant will die. Some plants can withstand a lot of flooding, some can withstand very little. Understanding these physiological mechanisms is important to knowing where a plant is appropriate for within your particular wetland. On a broader view, conceptually, once we understand plants are adapted to particular places, we can also understand that Choosing native species is important, and everybody really understands that native species are better than exotic species. But now we're beginning to understand that simply choosing native species is kind of a low bar. We should really choose species that not only are native, but are locally adapted. If you identify a source population, say, of willows that are just downstream from your restoration area, you should choose those willows as opposed to willows of the same species but from many states away. Populations are continually adapting to their environment, and if you choose a local population to source for your wetland restoration project, you are more likely to be choosing species that are better adapted to life in that exact specific environment. You'll have higher success than choosing species from further away. So, what are some of these methods? Just to kind of wrap up what we just talked about, it's important to choose the right species, native species, locally adapted species, and find the right location within your wetland for those species. Find that local source for the species and make sure your greenhouse, whoever you're having grow out that population, make sure they're using the right species from the right location. Find that right niche within your site for the species. Make sure that it can survive, it can continue to photosynthesize, it can continue to have success. Plants need energy to produce seeds and new individuals, and you want that population to grow. And then, of course, you just plant the plant. It's important to know what depth you plant it to. Should you use a potted plant or maybe just bare rootstock like in willows and cottonwoods? And then what density? You don't want to crowd them out, but maybe you don't want them to be too sparse. The jury's a little out, as you'll read, on how dense to plant plants. I hope you enjoy the videos from this week and your readings, and I look forward to the discussion we'll have.